When we hear about global warming, we usually hear about warming ocean temperatures, polar ice caps melting, and the sea level rising. What we hear less about are some of the other climate change effects that are predicted for the Pacific Northwest and how these changes might affect us and our communities. Living in Oregon, we know just how changeable our coast's weather can be, day to day, from season to season, year to year, and even decade to decade. This makes it difficult for us to tell if the changes we are seeing are part of a natural cycle or if they are part of a long-term trend caused by global warming. Jack, you've been working and studying the Oregon coast for some 20 years now. So what changes have you seen, both personally and in your data, that can help us understand whether the changes we're seeing are due to cyclical events or whether they're really long-term trends in our weather and climate?
The challenge is to get a record of that change. We have instrumental records for about 50 years, and then we have to rely on longer-term proxies, things like fish scales and the California current. So we can start to look for trends over these natural cycles. So let's just go back to 97, 98, biggest El Nino on record. And then in 2002, we had this strange water mass come down from the Arctic Ocean. 2005, the upwelling was basically late for a couple of months. That really knocked back the food web. 2006, the most severe hypoxia or low oxygen that we've had for many, many years. Now, the reason we can tell this is because we have 50 years of records. Early on, that was done with ships, people going to sea, taking water samples. But recently, we've been using these underwater autonomous vehicles. They're all self-contained. This flies under the water from top to bottom and sends the data back to us right here into the lab. So we can put together this 50-year record and then these modern measurements. And what we're seeing in the past 6 or 8 years is unprecedented. We're seeing low oxygens, even anoxia, which is lack of oxygen, and starting to see the ecosystem consequences of that.
And what are some of the theories for why these low oxygen events may be becoming longer and more intense?
And we think there's 2 reasons. One are the winds that drive the upwelling, and second, what's happening to the source water that comes up onto our coast. Now, the source water, we're detecting differences in the oxygen. It's going down over time, most likely due to climate change. The winds are changing, they're becoming stronger so that the upwelling is more intense, holding the low oxygen water up on the coast longer.
Scientists are already seeing an increase in winter storm intensity, particularly in terms of wind, rainfall, and wave heights. And these storms could increase in both frequency and intensity in the future, leading to increases in storm surges, coastal flooding, and stream flooding. The winter storms of 2006 and 2007 show just how devastating these events can be.
That 2006 event cost Tillamook County over $60 million in commercial, homeowner, and infrastructure costs. The last flood in 2007, also known as the December storm, which had sustained winds of about 129 miles an hour and a flood stage on the Wilson of about 21 feet, cost the area in excess of $43 million. We're still totaling that.
Climate scientists foresee the likelihood of more coastal flooding events in the future.
We know that a warmer atmosphere holds more water vapor, and that the simple expectation is that rainfall rates would increase in the future. And there's some evidence that in parts of the country and parts of the world that there is a detectable change in the frequency and intensity of rainfall events, pointing towards more intense storms, higher rainfall rates over the course of a day or a few hours. Will the storm tracks point more at us in the future, or less, or more or less the same? You know, if it's the same, we would expect an increase in flooding simply because of this effect of a warmer atmosphere with more humidity and higher rainfall rates. Another important factor for the coastal streams in the Northwest is the fact that some of them have watersheds that currently carry a snowpack in most years. And as temperatures rise, the snow line rises and there'd be less snow locked up in the mountains. And what that suggests is that fall and winter storms would likely lead to more runoff and more flooding in the fall and winter.
Changes in ocean conditions could have widespread consequences for those who make a living off the ocean. One emerging concern is the increasing acidity of the sea.
The corrosive waters are right up against our continental shelf. We can have an impact of ocean acidification on our fisheries. It turns out that the same processes that causes the dead zone in Washington, Oregon, and Northern California also enhance the ocean acidification process. When the organic matter dies and sinks to the sea floor, it consumes oxygen and releases CO2. The consumption of the oxygen causes the dead zone in a localized area. The release of the CO2 causes a far larger areal extent of ocean acidification. So you would have a confluence of these two processes reaching their maximum extent near the dead zones. So where we have a dead zone, I would also expect to see the most corrosive waters.
Scientists caution that whether we develop more or worse dead zones depends in large measure on the wild card of wind patterns.
When we have very intense upwelling winds, we get lots of that low oxygen, high carbon water brought up into shallow areas close to shore. And what the winds do in the future is critical for how extreme ocean dead zones become, how extreme acidification locally in the coastal waters becomes. And in my mind, it's one of the great uncertainties about where our coastal ecosystems are headed, in part because in the past we've had lots of variation from one year to the next, or even from 1 month to the next. And we know that it can cause huge changes in ocean characteristics that include temperature and oxygen content and acidity.
More broadly, climate change will affect fisheries, likely causing local increases in some species and decreases in others. Some changes would affect commercial and recreational fishing. Increased storm intensity and disturbances to our timberlands can cause jobs and revenue losses in our resource-based communities. Municipal water and sewage services may also be affected by the changes in rainfall, flooding, and sea level rise. Our homes could be threatened if forest fires become more frequent. Taken as a whole, the effects of climate change, both individually and cumulatively, will result in challenges to our coastal communities. Challenges that need thinking about sooner rather than later. And while the best information we have about these future changes has much uncertainty to it, climate scientists are clear about the direction of these trends.